Welcome to the online video tutorial series of distributed DPMS. In this video, I will explain more concurrency control algorithms. I am Jishan, Assistant Professor in IT-ICT Department of LJ Institute of Engineering and Technology. So when we are talking about concurrency control algorithm, it is divided into the two parts, pessimistic algorithm and optimistic algorithm. When transactions are accessing the shared data item, and during the accessing of those data items, if one operation is write operation, then we cannot acquire that type of operation, because if one data item is reading and second one is writing, then distributed serializability cannot be achieved. That's why we have to prevent that. On the basis of that, pessimistic algorithm is providing number of algorithms, and optimistic is all about we have to conclude this and we have to prevent that. So pessimistic algorithm is briefly divided into the centralized, primary, distributed, majority locking protocol and bias protocol. From that, first three is already covered in the previous video. In this video, I will cover first majority locking protocol. So when we are talking about the majority locking protocol, the majority locking protocol is satisfying all these disadvantages of distributed two-phase locking protocol. So when we are talking about distributed two-phase locking protocol, in that we have to take care about that all the data items which are shared and replicated at the different sites, we have to lock first that. Then after, lock manager is assigning those data item to the required transaction manager, and then that transaction manager is assigned to that particular transaction which is requested for that data item. But when the number of replica are available at the number of sites, at that time, every time we have to acquire the lock, and we have to synchronize it. We have to maintain the synchronization with the number of sites. So that is the biggest disadvantage. Every time distributed lock manager have to take care about that. So to prevent from this, we have to use majority locking protocols. So in majority locking protocol, we have to conclude this scenario. If data item replicated at M sites, the lock request is sent to the more than half of the M sites here. So we are not directly telling that we have to generate the answer of M sites. So here we have to use only major sites concerned here. So if we are talking about majority, then majority is all about half plus something. So here we have to take the consent from the majority of the sites. So from that, our lock manager determines whether the lock is granted or not. If requested is not compatible with the response, if the delay is required here, then request is granted here. In this method, if any number of transactions simultaneously hold the shared lock and majority copies of data item here, but only one acquire the exclusive lock. So here majority locking protocol is all about how the major of the sites is giving the response in positive manner that particular data item is not used by this current site. Then after, our particular transaction manager is giving the chance to that transaction to acquire the exclusive lock. So this is the basic idea how the majority locking protocol is working. Now the last protocol of two-phase locking protocol is all about bias protocol. So when we are talking about the different protocol rather than bias, then we have to take care about always which are the constraints are available. Is it a read operation or is it a write operation? So when we are talking about read and write operation, every time if read is there, then there is no need of reflection of everywhere. Because when we are assigning read authority to any transaction, then data is not changed. So to remove the consequences of previous algorithm, bias protocol is used here. So bias protocol is all about read lock and exclusive lock. So how the read lock is achieving here? So when the request is sent to the lock manager of one of the site that contains the replica of data item only. So read lock request is sent to the only single site here. We don't need to check any other site's condition, working condition right, because we are working on only read operation right now. So when we are talking about exclusive lock here, then we have to take care about that, because in exclusive lock our transaction is working on the write operation. So when the request is sending with the work of exclusive net, it is sent to the all that sites that contains the replica of data item. So two terms will be used here, read log and exclusive log. When we are using read log, then we have to check only one site, and when we are using the exclusive log, at that time we have to use all that sites that contains the shared data item. If the request is not compatible with the existing log status, then the response is delayed until the log is granted here. So this is the basic idea how our two-phase locking protocol is working. Now, pessimistic algorithm is based on timestamp base. So now let's discuss how timestamp based ordering is working here. So timestamp based ordering is divided into the three parts: basic TO, multi-version TO, and conservation TO. So when we are talking about first concept of timestamp ordering, so when we are considering the timestamp here in context of your log, we have to understand the basic scenario. So when you enter any real-time restaurant or any other places, at that time any number of token you receive when the systematic manner is following. Like that here, when the transaction is entering our system, one token is generated, and then that token is the timestamp for particular transaction. Then after, if any other request is generated or request is getting here, then that transaction is matched with that particular token number. If the token number is greater than the previous one, then our request is granted, otherwise not granted. So this is the basic concept how the timestamp ordering is working. So on the basis of that, three different categories working. But how the token is exactly generated here? Because when we are talking about the system is always continuously working. That is not same as our token number. So if system is working 24/7, 365 days, so token number is incrementally increase always. So one time what happened here, the token number is very large number. To remove this, we are using here timestamp as a token number. So when the transaction is entered our system, according to the system clock, we are assigning one time. That time is belonging to our system clock. So that system clock is assigned one time with exactly timestamp base, and that is the unique number for other transaction. So when the next request is coming in from the different transaction, it also assign one unique timestamp. When the timestamp is compared with each other, then we always know that higher number is always greater than the lesser time. So here unique ID will be generated for the first transaction which will be coming first. So the working of the first transaction is assigned first timestamp, that is the unique ID, and then after the second one is assigned. On the basis of that, three algorithm is working. So first algorithm is all about the basic idea about the timestamp base. So for that we can say that we are assigning the write timestamp and read timestamp. If the write timestamp is assigned to X variable, that is the largest timestamp of any read of operation. And write timestamp is all about the largest timestamp of any read on X here. So if you want to read any data item, so first we have to check what is the timestamp of that data item that is currently writing on that. Okay, if the writing operation is already completed, then we can read. If the writing operation is already on that, and if we are reading that, then the dirty data is read at that time. So that is not the fruitful for our particular algorithm. So that's why we have to take, if we are reading the data, then we have to check the writing timestamp of any other number. If we are talking about writing data item here, if I want to write the data item on my shared resources, at that time we also take care about that how the previously that data is read. If any data is read previously, that means our data is already read, no other transaction is writing on that. That's why we can write easily. So both the time when we want to access the read data item or write data item or shared resources, we have to take care about the timestamp of read of that variable. Okay, now move to our first algorithm, that is all about basic timestamp ordering. So what we are discussed here in the basic term of our timestamp algorithm, from that basic TO is working. So for read of Ix and write of Ix, we have to take care this condition. If timestamp of Ti is less than write timestamp of X, that is our first condition, then it is the rejected, because we already know here from the timestamp write operation is here big number. So for that we can say that this is a less number is always coming first in our timestamp base, so our request is rejected here. Else it is accepted here, and the timestamp, new timestamp will be assigned to our write operation. For the writing of any operation, we have to check this condition. If timestamp of Ti is less than write of our particular X and timestamp of Tij is less than write of X, then it is rejected, because timestamp value is here larger. If timestamp value is larger, then our particular timestamp is not satisfy this condition. That's why it is rejected. Otherwise, it is accepted, and the new updated timestamp will be assigned to a particular operation. This is the basic TO algorithm on that, the concept of timestamp ordering. The next algorithm is all about conservation TO. So here what happens exactly, if first transaction is accessing those data item and another transaction is requested for that and timestamp is greater here, so the request of that particular transaction is rejected. But how many times this request is rejected? Because that transaction is also acquire those shared data item to complete its operation. So how many times the same way particular transaction is requested again and again. And every time when the request is rejected, each and every background process is working another time. So too many restarts are required here with the context of delay. So for that we have to assure that number of restarts is becoming less as compared to basic TO. So for that we have to give the assurance to our system no major restart is occurring here. So for that no other operation with a smaller timestamp can arrive in the scheduler. So if transaction 1 is already working here, transaction 2 is requested and transaction 2 request is rejected here. Now transaction 3 is requested again. So what the scheduler is assigned here next? Transaction 2 is next number or transaction 3. So for that it will check again timestamp. From both the timestamp of T2 is less than T3, then it will assign a new request for the unique timestamp. And not that here delay may result in the formation of deadlocks here. If number of times we are restarted again and again same transaction, then next operation cannot be performed, and due to that our system may be occur in the deadlock situation. So in conservation TO we have to maintain number of restarts and deadlock conditions. Now we are moving to the third algorithm on the basis of timestamp, that is a multi-version TO. So here in timestamp ordering, first we have to maintain the original data. But this particular version is not modifying the original value here. Every time when the transaction is requested for shared data item, it always generated a new copy of that particular field here. So do not modify the value in the database, create the new value. That is the concept of multi-version TO. So if R of Ix is translated into the read of one of the version, then find the version of X here. Suppose X is my original value, then if any transaction T1 is updated X, then it is named as a X1. If any next transaction is requested here, it will check which one will be updated, X or X1. If X1 is updated, then new updates will be X2. So from that we are searching that which operations is performing which type of update and which version is most updated. From that we are checking that which is the currently most updated the value. But disadvantage of this version is we are unnecessarily generate the number of copies here. So in real time what happen here, if we are using this type of algorithm, then number of copies are increased and the size of the database will be increasing. So this is the basic idea how the particular data item is working on our pessimistic algorithm. Now we are moving to the optimistic algorithm. So when we are talking the optimistic algorithm, first we have to understand the difference between optimistic and pessimistic. So when we are talking about the pessimistic algorithm, first is validate the particular condition, then read the condition, then compute the operation, and last it perform the right operation. If we are talking about the optimistic condition, then first it read the required condition, then compute and then validate. So before the final commit, it will validate. Before that, it allows allow the transaction to compute its operation. So this is the basic difference between pessimistic and optimistic. Again, if we are clearing that in optimistic, when the transaction is trying to execute that, it is not forcefully say no here. First, our transaction is reading the condition, it computes its operation. Then after, our algorithm is checking that particular due to this operation, any concurrency integrity is violating or not. If the condition is violating that, then it is rejected. If not violating, then it is accepted. So this is the basic idea of optimistic algorithm. So we can say that here transaction execution model is divided into the sub transactions here. If Tij is that, then the transaction Ti is that execute at site J. If transaction run independently here, each and every transactions are working independently on the basis of reading phase. All the sub transactions are assigned here unique timestamp, and at the end of the read phase, it validates that which one will be updated. In the validation test, it's performed, the validation failed. If the validation is failed, then whole process will be rejected here. So if optimistic algorithm is working, then there are two validation tests here. First validation test is our Tij is reading, validating and writing. That is about Tij. If we are talking about Tk is completing reading, writing and validating. So if our Tk is completing write operation, and then after Tij is starting its read operation. So this is our basic condition here. If I am reading the data, the previous transaction is already completed the write operation here. So that is satisfied here. That's why we can say that validation is succeeded here. Now we are checking the next case where particular data item is failed to validate the test. So we can see here Tk is reading the data, validating and also then writing. But during the validating the test, we can say that here Tij is starting to read the data. So we can say that our data is already writing mode and next transaction is trying to read here. So when our timestamp is comparing here, then we can clearly see that this data item is lesser and this data item is having the larger timestamp. So directly we can see that our validation phase is rejecting this operation. So this is all about how the optimistic algorithm is working. So in this video, I have already discussed how the optimistic and pessimistic algorithm is working. Thank you for watching this video.